All right, so we're going to look at proving some inequalities. One of the key results that we're going to need is just to know that for any real number x, if you take that number and square it, it's always greater than or equal to zero. Because if you take a negative number, say, if you square it, you get a positive number. And if you take zero and you square it, you get zero. So we can actually use this result to prove a whole range of other inequalities. So let's look at doing something like that. So let's prove that x squared plus 5y squared is greater than or equal to 2xy. Well, just recall some rules about inequalities. We solve them the same way we solve equations you can move things to the other side, but if you multiply or divide by a negative number, you flip the sign. In any case, what we're going to do here is I'm going to take away 2xy from both sides. And so what we would have is x squared minus 2xy plus 5y squared is greater than or equal to zero. But I've dropped the greater than or equal to zero part because that's what we need to show. We need to show that that's the case, right? So what we can do is we can look at this first part and we can actually complete the square. If we treat x as a variable and y as the constant, we can sort of see that here we've got the coefficient of negative 2y. So if we half that and square it, we're going to get y squared. So we're going to add that on. So then that's sort of our first part. That's our completed square there. And then we're going to take away y squared because we added y squared. And then don't forget to add 5y squared back. And so factorizing this, we get x squared minus y squared all squared plus 4y squared. Okay, now sort of using this result here, this number is positive because it's something squared, and this number is positive because it's 4 multiplied by something squared. So we can in fact say that this whole thing is greater than or equal to zero. Okay, just graphically, I think it helps. Even if you haven't done too much 3D visualization of surfaces, just think about a simpler example for a moment. Think about y equals x squared. The graph of that is a parabola just centered on the origin. And I think you would agree that's always greater than or equal to zero. It's equal to zero at the origin, but other than that, the y values are always greater than zero. So what we can do is we can actually sort of do that in 3 dimensions. We can say z equals x squared minus 2xy plus 5y squared. And then just look, do our z values ever go below zero? And clearly not. Our z-axis is this blue axis. And at the origin of our 3D space, we can see that it's equal to zero, but everywhere else, our z values are greater than or greater than zero. And yeah, so that's it. That's what that surface sort of represents. Let me just explain that a little bit more. This sort of surface that we've got going on here, how was it created? Well, let's think if x is 1 and y is 1, and the z value happens to be 4. 1 squared is 1 minus 2 times 1 is negative 1. Altogether, this is negative 1 plus 5 is 4. So we get the coordinate 1, 1, 4. In any case, you're not going to get any z values that are less than 0 using this relation, using this surface, should we say. All right. Hopefully you found that useful. Good luck with everything you're doing, and I'll talk to you soon.